So I love Docker, but it wasn't always this way. Over the last 2 or 3 years, Docker's gone from this thing that I only vaguely understood to something that I use literally every single day. And to be honest, I can't live without. And I'm not talking about using Docker in a production environment, although I've tinkered a bit with a couple Kubernetes clusters at my day job. Instead, I use Docker every single day for local development and then for running tests as part of my continuous integration pipelines. But before I show you how I use Docker, let's briefly cover what exactly Docker is. And before we do that, I want to say there's so much that I wanted to cover on this topic that didn't make it in the video because I didn't want it to be 2 hours long or be too inaccessible to beginners. So what I want to do is a live stream, hopefully in the next week or two, where I do a deeper dive on some of the topics and then use it as an opportunity to answer like the common questions that people are leaving down in the comments. So be sure you're subscribed to get a notification when that live stream is going to take place. All right, back to what exactly Docker is. So in a nutshell, Docker is the platform for building, running, and sharing container images. Of course, that kind of begs the question, what the heck's a container image? And I think that is best explained by taking a look at a concrete example. Now, a lot of you are probably familiar with WordPress. To get WordPress up and running, you need a few things installed on your system. First, you need the actual WordPress PHP code base. You need a PHP installation to actually run that code. You need to store WordPress data like blog posts and images. So you need a database like MySQL on your system. You also need a web server application like Nginx to actually take the output from the PHP code and serve it to your visitors' web browsers. Now, traditionally, if you wanted to put WordPress on a new server, you'd have to install each of those things separately, plus any of their underlying dependencies. And it can sometimes be frustrating getting everything to work right, as something about your environment might be different than the tutorial that you're following. But using Docker, you could take all of those requirements, the web server, the database, the PHP runtime, and containerize them into an image that could then be run on any machine, your MacBook, a Windows gaming PC, a Linux server. And the only thing you need to install to get it working is the Docker runtime itself. Now, if you're familiar with virtual machines, you might be asking, why is Docker any better? Well, one benefit of Docker is that the containers share the underlying host kernel, meaning each Docker container can be smaller since you're not repackaging the kernel into each container. And that's nice, but the real magic for me anyway is the difference in how Docker containers are created. You see, a Docker container is built by reading the instructions from a Docker file, and a Docker file is just a plain text, easily readable document that contains all of the commands you would call on the command line if you were configuring a Linux server manually. Thinking back to the WordPress example for a minute, imagine you were following a tutorial to install all of the components necessary to run WordPress, install PHP, install MySQL, and so on. But instead of running each command manually, you can add them to a Docker file. Once you have that Docker file written, you can then use the command docker build, and Docker will go through the instructions step by step and assemble the container for you. So let's do exactly that and use a Docker file to build our own container. For this first example, we'll start with a really simple container that runs an application called PDF Toolkit. And PDF Toolkit, or as it's known, PDFTK, is a library that I've used a lot over the years to manipulate PDF files programmatically. And it can do a bunch of useful stuff like fill in forms, merge two PDFs into one, overlay a signature on top of a scanned document. But to compile PDFTK, you apparently need the GNU compiler for Java installed. The problem is that library was depreciated and is no longer included in recent Linux distributions. Long story short, if you want an updated operating system with all the latest security patches, you simply can't use PDFTK. But what if we were to build a Docker container running an older version of Linux that's capable of compiling PDFTK? Now, I've set up a Docker file to do just that, so let's go ahead and take a look at that Docker file right now. And that's it. Now, certainly Docker containers can get more complex than this, but just those 4 lines is all we need to get PDFTK running on any modern machine. Starting at the top, this from command signifies that we're using the Alpine Linux version 3.7 as our base image, and that was the last version to include the GNU compiler for Java. Next, we're using the docker run command to tell Alpine's package manager to add the PDFTK binary, which has already been compiled for version 3.7 of Alpine Linux. After that, we're instructing the container to set the working directory as home, and that just means that'll be the directory inside the container in which commands will be ran by default. And finally, we're specifying that the container's entry point should be PDFTK. This just means that when the container starts, it will call the PDFTK executable and relay it any parameters that were passed to the container. So let's go ahead and build this thing, and to do that, we're going to run the following command. We're going to say docker build, and then the period slash just tells Docker to use the current directory as the context for the build, so it knows where to load the Docker file from. Then we're tagging the build with pdftk-container, which will be how we'll reference it after it's been built. We'll execute the build command, and we see that the container was successfully built and tagged. Okay, let's take this container for a spin, and we'll use it to programmatically fill in a PDF form. Now, I've got a PDF in this directory containing an example invoice with some fillable forms for typical invoice stuff like your company names and your client names and an invoice number. And I've also prepared this .fdf file, which stands for Forms Data Format, and that's some standard PDFs use to fill in their forms. As you can see, I've pre-populated it with the data that I want filled in. You've got the value to be filled on the left and the form name on the right. So we're filling some fake company into the form named your company name. I mean, you get the idea. Okay, so with those two items set up, let's go ahead and run our PDFTK Docker container with the following arguments. We'll say docker run, and we'll pass the volume flag, which tells Docker to mount the invoice folder on this macOS host machine to the home directory inside the container. Remember, that was the default working directory that we set in the Docker file. And this will allow the PDFTK binary inside the container to interact with these PDF files out in the Mac OS host machine. And we're telling Docker which container we want to run, and it's the one we just built and tagged with pdftk-container. Then all of the arguments after that get passed to the container's entry point, which if you recall from the Docker file was just the pdftk binary. So we're saying take the template.pdf and apply the fill form command using the data.fdf file and output the filled form as invoice.pdf. So let's execute that, and you can see the invoice.pdf file has appeared. Opening it up, sure enough, the data from our data.fdf file has been filled in. So using containerization, we've been able to run some legacy software on a modern Mac without installing any dependencies other than Docker itself. And yes, I'm aware that I could have just used the Java port of PDFTK called PDFTK Java. But let's go back to the Docker file for a second. Remember that from command that was at the top of the Docker file? I mentioned that we're building our PDFTK container from a base image of Alpine Linux version 3.7, but when it says from, where exactly is that base image coming from? Well, the answer is a container registry, which is just a place where pre-built containers are hosted and made available through the Docker Registry API, and you can either pull those containers in to run them as is, or use them as a base image, as we've done with our PDFTK container. When you install Docker, the default registry is set to Docker's official registry called Docker Hub. Of course, you could change this configuration and use a private Docker registry to host your proprietary containers instead. But if you're just getting started with Docker, there's no reason to do that, as the Docker Hub is pretty much the standard place to find all public container images. And that's because anyone can push Docker containers to Docker Hub. Sort of the same way you can host source code on sites like GitHub for free, so too you can host Docker containers on sites like Docker Hub. In fact, let's push that PDFTK container that we just made up to my Docker Hub account right now. Now I've already logged in with my Docker Hub credentials using the docker login command. So let's quickly retag our container with my Docker Hub username as a namespace. So basically adding Ben Beerstrom and a slash to the beginning of the tag. And now if I simply run docker push Ben Beerstrom /pdftk-container:\latest, we'll see that it's being pushed up to Docker Hub. And if I refresh my repositories, there it is with the message that it was updated just a few seconds ago. And since it's public, anyone in the world can pull it down and make use of it. Because it's so easy and also free, there's millions of different Docker containers that have been uploaded over the years. In fact, there was already 94 PDFTK containers before I pushed mine. We probably could have just used one of those instead. But the point to take away is rather than starting from a base Linux distribution when you're creating a new container, you could just set your base image to a container that's pre-built and configured to run whatever application you think of. So what about running WordPress from a Docker container? Well, here's a Docker container someone pushed a few years ago that's configured to run a LEMP stack. And LEMP is an abbreviation for a web application stack consisting of Linux, your operating system, Nginx, the web server, MySQL, the database, and PHP, the programming language. And the name of the container is linuxconfig/lemp-php7. And what I like about this LEMP stack in particular is that the Docker file that's used to build the image is available for us to review. And if we take a look at the Docker file, you can see, like our PDFTK example, it too has a base image from another Docker container. In this case, linuxconfig/nginx. But here, instead of a major Linux distribution as the base image is another container uploaded by the same Docker Hub user that created the LEMP container that we're currently looking at, this Linux config user. So kind of like class inheritance with object-oriented programming, you can essentially extend your Docker container from a parent container. Here, this Linux config user has a base Nginx container that they've probably used anytime they needed a web server. But then when they wanted to add a container with PHP and MySQL as well, they simply extended from the Nginx container to add those additional services. So moving on from the base image, you can see that the Docker file is installing and configuring PHP, MySQL, and some PHP packages. And in the middle here, it's copying a file called index.php. And if we take a peek at the source code for that index.php file by looking at the GitHub repository this Docker container was built from, you can see the PHP code attempts to make a MySQL connection. And if it's successful, it'll simply display the PHP info output to the visitor's web browser. The other thing it's doing is installing and configuring an application called Supervisor. Now, Supervisor is basically an application that can be used to start, stop, and most importantly, restart other processes on your machine. For example, you can configure Supervisor to keep your web server or your database running in the event of a crash or a reboot. And if we jump down to the command that's run when we execute the container, you can see it's calling the supervisor daemon, which is just the server component of Supervisor that actually handles the process monitoring. Basically, the container is using Supervisor to make sure Nginx, MySQL, and PHP are running in the container at all times. All right, so let's pull this thing down and check it out. To pull it to your local machine, you can run docker pull, or you can just execute your docker run command and the container will automatically be pulled to your computer as part of the startup process. So let's go ahead and do that now. We'll say docker run, and we'll give the container we're running a name of lemp, and we'll bind port 8000 on our macOS host machine to port 80 inside the container, which is the port that the Nginx web server inside the container is listening on. And finally, we'll specify the container we want to run, linux config/lemp-php7. And if we execute that command, we get the message that it's not able to find the container locally, so it's pulling it from our registry Docker hub. Okay, we've finished pulling the container and it's currently up and running. As you can see from the output that after the container started, Supervisor spawned Nginx, PHP, and a MySQL process just as we expected. You can also see that unlike the PDFTK container that we ran earlier that completed its work and then exited, the Supervisor command is a long-running process. The container continues to run because the Supervisor process never ends, or at least it won't until we choose to actually stop the container. And if we open up our web browser and navigate to localhost port 8000, we can see the PHP info screen. Remember, this is what the default index.php file that was built into our container should output if everything was working correctly. But a PHP info output isn't terribly interesting. So let's go ahead and add a Wordpress install to this container. And to do that, we're going to extend from it in our own Docker file, which I have already prepared here. You can see at the top that we are extending from linux config/lemp-php7 and using that as our base image. Then we're downloading WordPress from the WordPress website and extracting it to the var www/html folder, which is the directory where the Nginx web server was serving that index.php file that we looked at earlier. And last but not least, we're copying this WordPress config file into the container. Taking a look, it's pretty basic stuff. We're mostly including it to tell WordPress to connect to the WP database using the user root with no password. And that's it. Let's build this thing and tag it with the tag WP. And now that it's built, we'll run it with docker run, and we'll give it the name of WP and bind port 8000 on the macOS host to port 80 inside the container. We'll also bind this data folder on our host machine to the folder where the MySQL data is saved inside the container, var/lib/MySQL. And if we didn't do that, then our database's data would live and die with the container itself. But instead, by mounting a volume from our macOS host in the place where MySQL saves its data, we ensure that the data is written to the host file system and is independent of the container, meaning we can destroy this container, replace it with a new one, and then point that new container to this shared volume, and all of our data will be intact. And we'll go ahead and execute that run command to start up our container. And if we navigate to localhost port 8000 in our browser, we can see this error message that WordPress can't find the WP database that we configured in our WordPress settings file. And that's because we've essentially created a brand new MySQL install when we built the container, so we need to create that WP database for WordPress to use. We can fix that real quick by executing a regular old MySQL create database command inside of our container. Now to execute commands inside of the container, we can use Docker's exec command, and we'll target the WP container by typing docker exec WP, and then the following is the command that will be executed inside the container, which is to call the MySQL command line tool and tell it to execute the following SQL statement, create database WP, using the root user with no password. And that's appeared to be successful. So if we refresh localhost 8000 in our browser, you can see we've been advanced to the WordPress settings page. Let's blaze through these settings real quick, click install WordPress, log in with the credentials we created, and boom, we've got the WordPress dashboard. So that's like all you need to run WordPress in a Docker container. Pretty cool, right? Well, not really. Even though building an all-in-one WordPress container is a good exercise to learn about Docker, none of what we've done so far should be used in a production environment, or even for development for that matter. And that's because we've been taking the wrong approach. You see, up until now, we've been configuring a single container to run multiple services. But as best practices have evolved over the years, the consensus is it's much better to run multiple containers with a single service in each. So instead of having PHP, Nginx, and MySQL all running in one container with Supervisor, making sure none of them crash, it's better to have a dedicated PHP container, a dedicated Nginx container, and a dedicated MySQL container. And I just want to say that I love the lemp container that Linux Config put together. I think it's a wonderful example of a really clean Docker file, which is why I chose it for this video. But I suspect that one of the reasons why the container is no longer maintained is because the creator came to a similar understanding that it's better to use single-purpose containers. And why is that? Well, there's a couple reasons. In a production environment, you could independently scale your services. For example, if your application container is under high load, you could add more app containers, each serving from the same source code without needing to add more web servers or more database containers. But where it really makes sense to use single purpose containers for my use case is that it makes it really easy to utilize generic officially maintained containers. Since you're not setting up a custom monolith to meet your exact use case, you can just use the official PHP container, the official MySQL container, and the official Nginx container, and get the benefit of regular updates from a huge community to help identify any potential issues. But having one container for each service can obviously get really complicated if you have a large microservice-based application with dozens or even hundreds of different containers. How do you keep them all straight? Well, in a production setting, you might use something like Kubernetes to dynamically deploy and scale all those containers. However, for local development and for continuous integration testing, which, as I alluded to at the beginning of the video, is my main use case for Docker, I rely on Docker Compose to orchestrate numerous single-purpose containers into an awesome local development environment. Now, Docker Compose comes included as part of the standard Docker installation, and you can access it by running the command Docker Compose. And if you look through the available commands, it's very similar to the commands that we've already been using as we explored Docker. We've got things like build and exec and run and push. And the same way that Docker containers are built from a plain text Docker file, so too a Docker Compose environment is constructed from a plain text Docker Compose file. And I think we're familiar enough now with how Docker works to just dive into a Docker Compose file and see how it's set up. So let's do that by taking a look at a Docker Compose file that I use for a side project of mine called Prezet. Now, my goal with this Prezet project is to create an opinionated boilerplate that I can use to get working right away on a new idea without getting bogged down with all the cruft that's involved when you're setting up a new web app. In a nutshell, it's a Laravel project running Inertia.js with a Vuetify front end. It's got two-factor auth enabled with the ability for a user to change their email and their password. And it has a Redis-based queue set up to listen for events and a WebSocket connection configured to push alerts to the user in real time. And most importantly, it has a continuous integration pipeline set up in GitHub Actions that runs automated tests and code quality checks and automatically deploys any tagged commits to the website demo.prezet.com. So if we open up the source code for the Prezet project, you can see this Docker Compose file at the root. And opening that up, we can see a number of different services defined, each pulling in their own container. We've got a container for our Postgres database, and one thing I want to call your attention to with the Postgres container is that we're binding port 54321 on our macOS host to port 5432 inside the container. Now moving on, we've got a container for our Nginx web server, then we have a PHP FPM container, which is responsible for running our actual application code. Next is a Redis container that we use for caching and queuing. Then we've got a Mailhog container, which is actually awesome for testing emails. I'm going to show you a bit more about that in a minute. And then there's a few more containers to process queues and schedule jobs. And there's obviously a ton going on here, but this video is going to get way too long, so we'll cover each of these services in more depth during the live stream. For now though, let's start our Docker Compose environment by running Docker Compose up in the terminal. If any of the containers we've defined are new to our machine, they will be pulled in or built automatically as part of the Docker Compose up process, just as we saw happen with the Docker run command. And we can see each of our services starting up, and we're getting standard out logging from each. You've got PHP FPM saying it's ready to handle connections. The Redis container is also ready. Postgres is ready, etc. And if we navigate to localhost port 8000, which is the port we bound to our Nginx web server container, we're greeted with the Prezet login page. Now, what makes this a powerful local development environment is since the code is mounted to the containers via a shared volume, any changes that I make to the code base will immediately be reflected inside the containers. For example, let's go ahead and change this login button to the site's secondary color instead of the primary, and we'll flip back, refresh the page, and sure enough, it's been changed. Now, earlier when we talked about the benefits of separate containers for every service, I talked about how easy it makes it to pull in all kinds of cool off-the-shelf containers into your local development environment. And one that I can't live without is Mailhog. In our Docker Compose, you can see we have the Mailhog container bound to port 8025 and 1025. The Mailhog container has an SMTP server listening on port 1025, and if we jump over to Laravel's environment file, you can see we've configured it to send mail to port 1025 on our local host. The point being that all mail generated by our Laravel application will be sent to that Mailhog container. The other port 8025 is connected to a web application Mailhog provides that lets us read the mail that was sent to the SMTP server. And if we open that up in our browser, we can see kind of what looks essentially like an email inbox. However, it's empty as no mail has been sent by our application. So let's change that by jumping back to our Prezet login page, clicking the Forgot Password button. We'll enter test@example.com and click Submit. And we see the message, a password reset email has been sent. Well, now if we flip back to the Mailhog tab, you can see that we have a new email. And opening it up, there's the password reset email our Laravel application generated. And clicking the reset password takes us to the next step in the password reset process. Now, a tool like Mailhog makes it really easy for us to develop and test application-generated email. And we could pull it into our development environment, completely free of charge with only 6 lines added to our Docker Compose. It's just incredible stuff. Now, I know this video is getting long, but I'd be remiss if I didn't touch on the Docker Compose network at least briefly, because I found that this trips up a lot of people the first time they're exposed to this stuff. You see, Docker Compose adds all of the containers it's orchestrating to an internal network, binds each of the defined container ports to that network, and gives each container a host name that matches the container name. What this means in practice is that if code is running inside a container and it wants to connect to another container, for example, when the Nginx web server container forwards incoming web requests to the PHP FPM container, it has to use the internal port and the container's host name. Now, this might make more sense with a concrete example. Here's a terminal open on my host macOS machine, meaning it's running outside of our Docker Compose network. And if I want to list the databases inside the Postgres container, I would run the following command. First, we're setting the environmental variable pgpassword equal to Postgres, which happens to be the password for the database running in our Postgres container. Then we're executing the psql binary, which is a command line tool for interacting with Postgres databases. And we're saying connect as user Postgres on the hostname localhost on port 54321. And we're asking it to list the available databases with the L flag. But if I execute that same command inside of our PHP container by prefixing it with the docker exec command that I showed you earlier, you can see we get an error. Could not connect to server, connection refused. Is the server running on localhost and accepting connections on port 54321? Well, as it turns out, the server isn't running on that host port, at least not in the Docker Compose network, which is the network the container is connected to. Instead of specifying localhost and the port we bound to the macOS machine, we need to specify the container's name as the host name and pass in the internal container port of 5432. And after updating the command, we can see it executed successfully. What this means in practice is if you're, say, running your automated tests from outside the container, you would need to configure a different database connection for those tests. Of course, you could easily run your automated tests inside the Docker container using something like docker exec PHP unit. Finally, let's talk about how I use Docker Compose as part of my continuous integration pipeline. I mentioned that I have this Prezet codebase configured to run automated tests and code quality checks as a GitHub action. So let's take a look at that now. You can see up in this GitHub workflow folder, I've added a file called push.yaml. And at the top of the file, I've specified that this workflow should run on all pushes and pull requests. Basically, anytime you push a new commit to this Prezet repository, this workflow will run. And moving down, you can see we have 2 jobs. The first is called test, and it runs on the latest Ubuntu Linux, which is nice because it already has Docker and Docker Compose installed and ready to go. Next, you can see we start Docker Compose. That D flag indicates we should start in a detached state. Otherwise, the terminal would stay connected to Docker and we wouldn't be able to run any additional commands. Once our Docker Compose environment is up, we install our PHP and JavaScript packages. And what's really great about executing those commands inside our Prezet PHP FPM container using docker exec is Composer and Yarn are already installed in our container. There's no need to install them in the Ubuntu environment where we're running this GitHub action. Moving on, we've got some artisan commands and some code quality checks, again running inside the Prezet PHP FPM container. We compile our JavaScript just to make sure there's no errors, and finally we run our PHP unit tests. And I know that I need some JavaScript tests as well, but like I said, this is a work in progress. And if we don't get any failures and this commit is a tag, then the next job called release runs, which automatically deploys the updated code to demo.prezet.com. But since I'm not using Docker in production, that's all beyond the scope of this video. But I hope you can see what's really cool about running the tests in the container spun up by Docker Compose is any dependencies the tests rely on are available since the environment is identical to my local development environment. For example, any PHP extensions I've added will be there along with a Postgres database connection for any integration tests. Whew. We covered a ton of ground in this video. If you're new to Docker, I hope you can at least see how incredibly powerful it can be and got some good ideas for how to harness that power for your future projects. We move really fast, so I'm sure there's tons of questions. If so, leave them down below and I'll try to answer them as best I can during the follow-up live stream. Again, make sure you're subscribed so you get notification when that's going to happen, hopefully in the next week or so. So that about wraps it up for now. As always, if you've made it this far in the video, know that I really appreciate you taking the time to watch, and I look forward to seeing you in the next one.